Good afternoon. All right, let's see. All right, so Jada's not there yet, and Hopi, is she? Not yet. All right, we've got Weston and Tobias here. Um, so Weston, did you see Avengers yet?
Yeah.
How about you, Tobias?
Yeah.
All right. So did you guys know that it broke the $1 billion over the weekend worldwide? That's just insane. But anyway, did you like it?
Yeah, I cried.
You cried? I thought it was epic. I thought it was an epic movie. So uh, anyway, it was amazing. Um, anyway, I'm not sure about all the time travel stuff, but I thought it was pretty legit. It was a lot of fun. It was a good movie. So anyway, um, well, let's. Oh, there's Jada coming in, I think. All right. So hey, hey, let's see. So today, what we're gonna do is we're gonna finish up 11:3 and do 11:4, which is also very super short. So let's see. Is this the is this kind of where we were? I don't know why. I guess I was excited to start the weekend, and I didn't mark where we finished up. So, um, so I have on the back page. Is that where we were? Yeah. Okay. All right. Well, we'll pick it up from there. So, any questions, comments, concerns before we get started? Okay. Oh, I lost me. Let's see if I. Okay. Okay. All right. Um, can y'all see the board and see me? We're good. Okay. All right. I had to monkey with the cameras there to get them to work. So, anyway, um, so so Jada, did you see the Avengers movie yet?
Yeah, it was good. I really liked it.
All right. Okay. Awesome. Well, anyway, so I was reading an article about that Marvel was actually upset with Sony because Sony started promoting the Spider-Man movie, and they didn't want people to know that he was going to be alive or not. He's going to be okay. So anyway, it's kind of interesting how that worked. But anyway, um, so I'm just curious at all the theaters you were at when they come back, did everybody start cheering? Yeah. How about where you were at, Jada?
No, actually, I don't know. It was weird because there was this girl sitting by me and she looked at me all weird because I got all hyped. And I just looked at her like, what are you doing here, Dan?
Yeah, really. What? Now, where did you see it at?
I saw it at Scottsdale at the Fashion Square. They have a
Oh,
movie,
okay.
a cartoon in there.
Wow. Well, when I saw it, and I mean, everybody was cheering and going crazy. That part was a lot of fun. So, Anyway, so I guess Scottsdale, maybe they're kind of lame. But anyway. All right, well, let's just go ahead and start. So we're on the second page of 11.3. So we've got the equations relating polar and Cartesian. So all of this is review. And so I kind of put this, you can put these on the first line and then these on the second line. So to go from polar to Cartesian, the xy, you use x equals r cosine theta, y equals r sine theta. And then to go from Cartesian to polar, you use these two, r squared equals x squared plus y squared, and tangent theta equals y over x. Okay? So those are kind of the equations that you need for all of these. So here it says, here are some plane curves expressed in terms of both polar coordinate and Cartesian coordinate equations. So for polar, if you have r cosine theta equals 2, well, so if r cosine theta equals x, you just replace that with x, and so you just get x equals 2. Okay? Or here, if you have r cosine theta times r sine theta equals 4, well, r cosine theta is x, r sine theta is y, so this would just be x times y equals 4. Now, the thing that's a little tricky, though, is that this might be written like this. And so where you have the r squared. And so you might not know what to do with that, but if you kind of peel off one of the r's to go with the sine theta and one with the cosine theta, then and rewrite it like that, then you can kind of see what you need to do. Okay? All right. So let's see if you can do, there's two here that are in polar. See if you can figure out how to rewrite them in Cartesian. All right, so Jada, what do you have for the first one?
I got x squared y squared equals 1.
Yeah, so x squared minus y squared.
Oh, damn it. Look right. Okay. Oh, sorry.
Okay. And let's see. Weston, how about the second one?
The closest I can get is r equals 1 plus 2x.
Okay, so the 1 plus 2x is right. But see, to put it in Cartesian, you have to get rid of the r. Okay, you can't have an r and a theta. Cartesian just means in x and y. So, so what you do is if you actually think of r squared is x squared plus y squared, and then take the square root of both, then you can think of this as the square root of x squared plus y squared equals 1 plus 2x. All right, so does that make sense? So you're just getting rid of the r. Okay? All right, good. All right. So some curves are more simply expressed with polar coordinates. Others are not. It really just depends. Sometimes it's easier to manipulate in polar coordinates. Sometimes it's easier in the XY Cartesian coordinates. It depends on the situation. All right. So now we're going to go back the other way. So this is in Cartesian with X and Y, and we're going to put it in polar, R and theta. All right. So kind of the way you do that, if this part is squared, what we want to do is square this out. So that way we can combine the x squared and the y squared and make that r squared. Okay. So first we're subtracting 9 from each side, and then replacing x squared plus y squared with r squared, minus 6 times, and then y is r sine theta. So y is r sine theta, x is r cosine theta. And so we're done. So that's it. Okay. Now, sometimes you'll see these polar equations where they'll want you to keep working it till you get r by itself, till you solve for r. So if that's the case, then what you would do here is factor out an r and then set each factor equal to 0. So you get these two equations, r equals 0 and then r equals 6 sine theta. So that's usually the preferable way to do it. So even once you get to here and you don't have x's and y's, they'll kind of want you to keep manipulating it till you just get r equals for your polar equations. All right. Okay, so go ahead and try practice 5. All right, so Toby, when you've got it.
I got r squared minus 10 r cosine theta equals 0.
Good. Okay. Now, what if I wanted him to solve for r instead of r squared? Okay. Let's just go ahead and do that just in case. So you would factor out an r and then set each factor equal to 0. Okay. But usually this part, what you said, would suffice. Okay. All right. All right. Any questions on that? All right. So again, kind of more of the same. Just another example. The key to doing these is to remember the formulas. Is that if you forget the formulas or if you don't have them in front of you, usually you're stuck. You know, you can't, because they're not real intuitive. Like you're not going to just figure it out. You've got to know the formulas. Okay. So this is rewrite. So x squared minus 2x plus y squared equals 0 in polar form. All right. Now, here's the... Okay, so here's the easy way to do this, is that if you think, okay, the x squared plus y squared, that becomes the r squared, okay? So this becomes this. And then minus 2 times, okay, now x is r cosine theta equals 0. And so then that's your answer. Okay, or once again, if you want to factor out the r and set each one equals 0, then that could be your answer there. Okay? All right, so go ahead and try practice 5.5. All right, Jada, what do you have?
Oh my god, r squared equals 81.
Okay, and then what if you took the square root of both sides? What would you get?
9.
Okay.
R equals 9.
So r equals 9. Now you might say, well, what about plus or minus 9? Well, so the weird thing in polar is that r equals 9 and r equals negative 9 is going to give you the same circle. So r equals 9, that's a radius of 9. But when you do an angle, if you have r equals negative 9, you're just going to get the same circle. It's just going to be on the other side because you go backwards when your r is negative. Okay? So you'll get the same circle, right? So r equals 9 would be where we'd want there. Okay. All right. Okay. So now rewriting a polar into Cartesian. So once again, you're going to start off with your equation in r and theta, and then you're going to end up with x and y. Okay. So it says replace the following polar equations by equivalent Cartesian equations and identify the graph. So that just says, tell me what the graph is. Is it a circle, an ellipse, a parabola? What is it? A line. Okay. So here we have r cosine theta equals negative 4. Well, if you just replace r cosine theta with x, you get x equals negative 4. And that's just a vertical line. Okay. All right. So go ahead and do practice 6. All right, Weston, what do you have?
Okay, I don't know if this is right. I think I got it. Y equals the square root of 4x minus x squared.
Okay. But now you don't have to solve it for y. But let's just, okay, so you did. So, but do you know what shape that is? Do you know what What's that? What that's the graph of?
It'd be a sideways parabola.
Okay. Well, let's check it out. See if you leave it as x squared plus y squared equals 4x. Okay, and then you solved it for y, right?
Yeah.
But see, the problem is that when both of them are squared and they have the same coefficient, that's a circle.
Okay, yeah, you're right.
So this is going to be a circle. Now, you could have recognized that here if you want to, bring the 4x to the other side and complete the square, then you can say, oh, this is a circle with a center at 2, 0 with a radius of 2. Okay? So, but you could tell that it's a circle from this point, because if they're both squared and they have the same coefficient, then it's a circle. Okay? So that's really all I was kind of after on that one. All right? So the parabola is the one where you only have one squared term. Okay? All right, any questions on that? All right, well, so that's it for 11.3. 11.4 is also very short. It's on graphing polar coordinate equations. And this also has no calculus in it. But it's a good review for, Calc 3. So it's good, but anyway. All right, so the first idea here is what we call is the symmetry. Talking about the symmetry. All right, now let's see if I can. I'm gonna kind of draw the lines here, separating this. Okay. I don't know how to write that. Okay. Well, let's just go through it here. Okay, so in Cartesian, you have what we call symmetry around the x-axis, where one side is the mirror image of the other. But in polar, that's not called the x-axis, it's called the polar axis. So instead of symmetry about the x-axis, you need to think polar axis. And then if the point r theta is on the graph, then r negative theta is on the graph. Okay? So you just change the theta. So like if you had 3 20 degrees, then 3 negative 20 degrees would be on the graph, because it's symmetric to the polar axis. All right, the second one. If it's symmetric about the y-axis, see, there's no y-axis in polar. But this line, this vertical line, it's the line theta equals pi halves. That's the angle. So if it's symmetric about that, then if a point r theta lies on the graph, then the point r, and then the supplement. The supplement is on the graph. So either 180 minus theta or pi minus theta. Is the angle. The r is the same, but it's whatever the supplement is. So if you have the point, let's say 220 degrees, then the point 160 degrees. It's going to be on there. Or if you have the point 380 degrees, then the point 100 degrees would be on there if it's symmetric through the y-axis, or theta equals pi halves. Okay, the last one is if it has symmetry about the origin. In polar coordinates, we say that it's symmetric about the pole. And so then if the point r theta is on the graph, then it also the point negative r theta, so going the other way, would be on the graph. So like if you had 20 degrees and it's symmetric through the pole, then negative 20 degrees would be on the graph. Okay? All right, so let's look at an example. Here it says graph the curve 1, r equals 1 minus cosine theta, and describe the symmetry. Okay, so to graph these polar coordinates, all right, the first thing that you need to be able to just plug in angles. So the first way I'm demonstrating this is just making a t-chart. Okay, so you come up with the angle 0, pi thirds, pi halves, 2 pi thirds, pi, and plug in. So if theta is 0, the cosine of 0 is 1, so 1 minus 1 would be 0. All right, if theta is pi thirds, the cosine of pi thirds is a half. So you get 1 minus a half is a half. If theta is pi halves, the cosine of pi halves is 0. So you get 1 minus 0 is 1, and so on. And so then you go through and you plot the points. So you plot these points, and so you get kind of this heart-shaped graph here. Okay? Now, to actually do it in the calculator, you can just, let me just kind of show you how to graph it in the calculator like that. Maybe. There we go. All right. So to put it in the calculator, the first thing you want to do is check the mode. Now, you need to be in radian mode, which we are, and then you need to be in polar mode, which we are not. So we're going to go through and change from function, parametric, and then polar. All right, then when we press the y equals key in polar mode, it actually comes up with r. So we want to type in 1 minus cosine theta. So 1 minus cosine, and the theta in the polar mode, the variable key just comes up theta. So 1 minus cosine theta, and you press graph, and so there you go. Right? So then as we look at the symmetry, this is symmetric upon the polar axis. Okay? The positive x-axis. So it's symmetrical there. Okay? So then you would say symmetry, it's symmetrical about the polar axis. Okay? All right. So go ahead and try this one. So graph r equals 1 minus sine theta. All right, so Tobias, how is this symmetrical? 1 minus sine theta. Whoa.
I got the symmetrical about the y-axis.
Okay, except, but you don't call it the y-axis in polar. So what do you call
it? Is it the supplement? I don't really know.
No, it's theta equals pi halves.
Oh,
That's you're just telling the angle. It's like your angle is 90 degrees or pi halves.
Okay.
So theta equals pi halves is that line. Okay? But you're right. That is the symmetry. Okay? So symmetrical about theta equals pi halves. Let me write that up. Okay? All right. Any questions on that? Okay? All right. Now, there's 4 types of polar graphs. Okay? Number 1 is a rose, which just any flower-looking thing, we just call it a rose. Number 2 is a limacon, and it basically looks like a lima bean. That's how I remember lima, and it has this little indentation like a lima bean. Number 3 is a cardioid, okay, like a cardiac arrest. It's a heart. So if it has a heart shape, then that's a cardioid. And then the last one is a limnoscate, and it just has, if it looks like a figure 8, then it's a limnoscate. So I just think figure 8 limnoscate. Okay. Okay, so let's say we wanted to graph this, and we wanted to determine what type of polar graph it is. All right, so r squared. Now, when you press the polar mode, it's just r equals, not r squared. So in order to punch this in, you actually have to enter it in as 2 separate graphs. Because when you do the square root, it's plus or minus the square root of 4 cosine theta, or plus or minus 2 radical cosine theta. So you're actually going to have to enter this in as 2 different functions. So for your R1, you would do 2 square root of cosine theta. For the R2, you would do negative 2 square root of cosine theta. Basically, one is going to be like the top half, and the other is going to be the bottom. But when you put them together and you look at the graph, well, it kind of looks like a figure 8. So this would be a limnoscate. Okay? All right, so go ahead and try practice 2. All right, Weston, what do you have?
It is also a lemniscate.
A lemniscate? Yeah. So you do square root of sine 2 theta, negative square root of sine 2 theta. And so, yeah, it's a figure 8. It's a little tilted, but this is also a lemniscate. All right? Good job. Okay, so that's it for 11.4. Any questions? All right, well, I think that's a good place to stop. So, anyway, so we've got 11.5, 11.6, and 11.7 to do this week. And I think we're on good pace to do that because 11.5 is a little short. Anyway, so we should be able to do that. And again, that my plan is that next Monday we'll have just sort of we can either do a review day or a Moodle day, however you guys want to do it. We can talk about it later this week. If you want to have next Monday be a Moodle day or a review day, and then we'll start the final on Tuesday, Wednesday, and Thursday. Okay. All right. Any questions? All right. Well, Avengers disassemble. You guys have a great day, and we'll see you tomorrow.
In my opinion, I think Thor was the most attractive in this movie.
Well, you know, I always said I wanted to have the body of Thor, and now I got it, right? So,
Yeah.
anyway, so yeah, be careful what you wish for, right? So, happens to the best of us.